Hi folks, welcome to the first MLO for your unit on radicals, which is Unit 5 in the course, Chapter 4 in your textbook. Alright, so we're going to talk about creating entire radicals from mixed radicals, and then we're going to talk about how we order entire radicals or order mixed radicals by making them entire. So those are sort of the two major topics that we have to get on here, and let's roll right into it. First of all, some terminology review. Most radical expressions that are simple are monomial radical expressions. Look kind of like this. So we got sort of three important parts here. We know it's going to have one of these root thingies, so we're not really talking about that. That's part of any radical expression. But the three things that sort of go around that root are, first of all, this little tiny guy up here, that a, that's what we call the index. And that tells you if you have a square root or a cube root, depending on what that number is. Okay? And then the stuff that's hiding underneath the radical sign is called the radicand, and that's the thing you're trying to take a root of. And then the number that's out in front there is what we call the coefficient of the radical expression. All right, so maybe we'll just scribble a little example over here. If I had, say, 10 times the cube root of 5, like that, then in that particular expression, our index is 3 because it's a cube root, our radicand is 5, and our coefficient is 10. So things we need to remember about all that: entire radicals and mixed radicals are different. This expression that we wrote over here is a mixed radical because of this 10. Part of it is under the radical sign, that being the radicand, and part of it is not. So because we have two sort of different kinds of numbers, it's a mixed radical. If the coefficient out in front is a 1, or if b equals 1, then we would just have an entire radical. No coefficient out in front, because we don't need to write a 1 for a coefficient. So there's no sort of whole number part, just the radical part. Okay, on we go. So the next one, we're going to talk about now converting mixed radicals to entire radicals, which is sort of the bread and butter of this section that we're talking about today. So what we have to do is we have to take a mixed radical like 5 square root 3, and we have to convert that into just one single mixed radical. And it helps to remember, if we're going to do that, that if I take two radicals like, let's say, square root 7, and I want to multiply it by the square root of, I don't know, 3, then it's real easy to do. All I have to do is take the square root of 7 times 3, which is 21. Now, that means if both of these things I wanted to combine together here to make one entire radical were both radicals, then I could just multiply the radicands. I can't multiply the 5 by the 3 and get square root 15, though, because there's no root on the 5. So what I do is I just sort of cheat, and I change the 5 into a square root. And we should know that the square root of 25 is the same thing as 5. So we take 5 and we square it and call it a root. Basically, that's our little cheat method that we do here. So we have square root 25 times square root 3, and then all I have to do is multiply those together. 3 times a quarter is 75 cents. So we have the square root of 75 right there. Okay, so that's an entire radical that's equal to this mixed radical. Let's try this one. In this case, we've got a negative 2 as our coefficient, but that's okay because we have a cube root, and as we'll see in a later section, when we're dealing with odd powered roots, it's okay to have negatives under the radical. Not so good for square roots and fourth roots and such, but we'll get into that detail later. So the first thing we're going to do here is we want to convert the negative 2 into a cube root. So let's see, what would I get? A cube root of what number would give me 2? Well, let's see, 2 times 2 times 2 is equal to 8, right? So I can say that the cube root of negative 8 would be equal to negative 2. All right, and that's multiplied by the cube root of 7. So I can multiply those two things together. That becomes the cube root of negative 56. Okay, so I have my cube root of negative 56 here and my square root of 75, and I've created entire radicals from mixed radicals. And that's all there is to it. Okay, so the last sort of skill thing we have to be able to do is if we have a whole bunch of mixed radicals or entire radicals, we got an entire radical here, 3 mixed radicals, and we've even got a whole number, and we want to order them from least to greatest. That's hard to do just by looking at them. But if we can convert them all to entire radicals, we'll be in business. So these are all going to be square roots by the looks of things. So let's start with that 4. Pretty sure that's the square root of 16 because 4 squared is 16. And then we'll take 4 square root 3. What's that going to be? Well, that's square root 16 for the 4 part multiplied by square root 3. And let's see, what's that? The square root of 48 when I multiply those together. All right, So let's check out square root 14. Oh, wait a minute, that's already an entire radical. Nothing to do. All right, so let's take a look at 3 root 2 now. That's going to be the square root of 9 times the square root of 2, because 3 is the same as the square root of 9. So that becomes square root 18. Okay, that's pretty good. And then the last one, we've got 4 times root 5. So we already know 4 is the same as square root 16 multiplied by square root 5. So I guess we can call that square root of, let's see, 5 times 10 is 50 and 5 sixes are 30. So I guess that makes square root 80, doesn't it? So now we just have to order these things. So the smallest one I see there, I guess for all these entire radicals, is square root 14, which started off as square root 14. So I'm just going to write it that way. And that's less than the next one we had, which I guess is going to be this square root 16, and that was just a 4. And so I've got those two taken care of. And then the next one is square root 18. So that's less than square root 18, which was originally 3 root 2. And then we've got square root 48 over here. So we're going to call that square root 48 was 4 root 3. And then the very last one was this root 80, which is 4 root 5. And what we've done is we've taken the big old mess we had and we sort of sorted it out in terms of which ones are bigger and smaller. Okay? Not so much to that. So let's just keep in mind to convert mixed radicals to entire radicals, we write the coefficient as a radical with the same index as the other part of it, and then we just multiply our radicals together. So to order them, we convert all the mixed radicals into entire radicals, and then we just reorder them by comparing the radicands of, and this part, make sure you know this part is of the entire radicals. Okay, and that's it. Okay, see you in the next session. Bye-bye.